In this presentation, we're going to talk about trading off between fairness and accuracy, which is part of the machine learning series, specifically concerning bias. So we'll do our familiar 6-question framework, skipping this time number 5, which ethical value is relevant, which is, of course, fairness. Okay, what is the problem? And so here's how I've chosen to lay this out. This is a kind of a logical reconstruction back in my formerly trained as a philosopher. So we like these syllogisms, right? So each one is a premise, each line is a premise or a conclusion. If it says therefore, it's a conclusion, otherwise just a premise. Just to kind of walk us through the thinking. Okay, so first of all, we want predictions that are fair. I have that bolded and asterisk because I want to say more about that in a second. Second, we can't guarantee fairness by looking at the inputs, that is to say the data. And I've discussed this at length in other videos in this series. Third, we can't guarantee fairness through feature selection. I've also discussed that at length elsewhere in the series. Okay, so what that means is that we have to look to the outputs. Not saying that we should just completely give up on the inputs. I mean, we should still care about that, and there's still plenty of good work being done, and that should continue. But if you're at the place where, I discussed, there are some problems that are fixable. Data that's not representative, I think, is a very fixable problem in most cases. Data that contains a historical bias, I think, is very difficult to debias. But again, people should still try. There are very smart people working on this problem as we speak. But let's shift from thinking about the data that goes in and trying to make that fair. How can we make sure the outputs are fair? Okay, so if we're going to look at the outputs, one thing to think about is that we can't guarantee fairness by maximizing for accuracy. That sounds a little surprising, or I guess it might sound surprising, but I want to say more about that. That's why it's asterisked and bolded. So we need to combine fairness and accuracy. We have two metrics that we care about, two values that we care about, the value of accuracy and the value of fairness, and we need to put them together. Unfortunately, sometimes, not all the time, but sometimes they are in tension. So in the times when they are in tension, we need a principle or a way to think about best practices for trading off between those values. Okay, so let me follow up on the premises 1 and 5 here. So let me ask a kind of a strange question. Why do we want fair predictions? I say it's strange because for a person that cares at all about ethics, it's very obvious why you want fair predictions. But what I want to emphasize is that fairness is not some kind of luxury. It's not some kind of add-on. It's not some kind of nice to have. First we need to make sure the model's accurate, and then we can kind of like add in this nice little extra thing, fairness. If that is the picture that you have in mind, I want you to drop that picture because it's not true. Okay? Fairness is something that you should want if you want your model to work, if you want your model to actually be accurate. Okay, so here's why. So if you say, okay, I'm not going to care about fairness, let's just maximize for accuracy. What you're actually doing is not maximizing for accuracy itself, but maximizing for accuracy relative to the data set that you happen to have. And as we discussed, there are some very good reasons to worry that your data does not perfectly represent the world, right? Either because it's just not representative of what's going on there, or because it contains historical bias, or because it was cleaned improperly. Okay, so what I'm saying, shockingly, is that if you maximize for accuracy, your model is almost definitely going to be inaccurate. Weird sentence, but I stand by it. Okay, so how should we get through this? So what I suggest is that we not focus on the term fairness. I like the term fairness. I think we should keep using it. I want to get back to it. But just for this particular presentation, let's step back from it. And the reason is because if you have two fighters, fairness and accuracy, two values, and you got to trade off between them, well, which value is going to win? inevitably, as people are sitting around the boardroom trying to make this product, right, accuracy is going to win. If it seems like we have to either care about accuracy or fairness, then we're going to end up favoring accuracy. But again, that is a poor framing of the problem. Fairness is not a nice to have, not an add-on that we might want. So what I suggest to clarify is that we rename fairness as accuracy relative to the real world. Right? So that makes it clear that fairness is not some kind of extra woke thing that we just want to put in there to make our model fancy. No. Fairness is accuracy relative to the world as it actually is, or actually should be, I should say. And then accuracy, let's also rename that. Let's clarify that when we talk about accuracy, really we're talking about accuracy relative to the data set that we have. Okay, so now we have kind of a more fair fight, right? We have accuracy sub RW, or it's not written as subscript there, but and accuracy sub DS. Okay. Another point that I wanted to throw out there is that we also, I've made the case, I've spent time making the case for fairness, or now we can call it accuracy RW. But, we also can't just abandon the data. The data is the basis of the model. It's how the model is trained. It's how the model is validated. It is, in a sense, the ground truth of the model. Now, I insist that we don't blindly just trust the data. I think that's a very bad idea. I've talked about this all over this series, including in the problem of raw data that you can take a look at. But the data, sure, okay, it has value, but you don't just blindly accept it, right? So you have to, what we would say now, trade off between the accuracy relative to the data set and accuracy relative to the actual world. All right, what's familiar about this problem? So let's think about this in a different context. Let's imagine that we're trying to think about not the best kind of model, but the best kind of society. And for this, I'm asking you to believe two unrealistic things. One unrealistic thing is that each of these societies, so there's 4 societies, each column is a society. I'm asking you to imagine that each society only has 3 people in it. I know that doesn't make any sense, but just for this thought experiment. Second unrealistic thing I want you to imagine is that the happiness of each of those people in the society can be perfectly measured with a number. Okay, so 10 is very, very, very happy, extremely happy, perfectly happy maybe, and 1 is just absolutely miserable. Okay, so we could ask this question: which of these 4 societies is the best society? So there's different things that you're going to want to say. So one plausible argument you could make is for society 2, and the reason that some people might prefer society 2 is that overall, on balance, in aggregate, there is the most happiness in that society. Okay, so we can look at again. We found a magical way to quantify happiness, right? In this system, we can observe that society 2 has the most happiness, and therefore it's the best society. Okay, now some people, a lot of people actually, see that, yeah, there's the most overall happiness in the society, but maybe we're more interested in how that happiness is distributed. Okay, so if we're interested in that, we are going to be probably more attracted to society 3. Okay, society 3 doesn't have quite as much overall happiness as society 2, but if you look through the numbers, 8, 7, and 6, there is more, and that I might ask you what you like about society 3, and inevitably someone says equality. the best off and the worst off aren't very far apart. Equality is an excellent value for lots of reasons that we don't need to talk about here. Although I want to push you on this for those who favor Society 3, as I actually do personally. I would ask you, is the only reason you like Society 3 because of equality? Because if all you like is equality, you actually should favor Society 4, because Society 4 has perfect equality. So, I don't think you should like Society 4, right? If you like Society 4, all you care about is equality, and you don't care that everyone in the society is unhappy. And I think that would be a weird moral position to take, that all you care about is equality, and if people are equally unhappy, then that's fine with you. I think you should want Society 3. So what Society 3 has is not just equality, more equality than Society 2, but that the least off is not doing very poorly, right? So if you look at, compare the societies, the worst off in society is a 6, over the threshold of being more happy than more unhappy, right? And so I think it's those two factors put together that we like the equality of it, but it's not just the equality, it's that the least off is doing the best off compared with the other societies. Okay, so let's, I'll come back to that. I want to talk at length again about our 4 societies. But let me just step away from that conversation just for a minute. Well, not totally, because right, trade-offs like those, like the ones we just talked about, clearly have ethical consequences, and they are ethical consequences that are public, that are out there, right? We have people living in mansions and people living on the street, and so that attracts debate, public debate, right? We don't want our neighborhoods to look like this. We do want our neighborhoods to look like that. We don't want our schools to look like this. We do want them to look like that. Public debate, disagreement, and ultimately, in a healthy democracy, compromise. Okay? So because of the capabilities of digital technology, algorithms also navigate, they have to, the models that we have to navigate these trade-offs, but they are doing it without public debate. And they're doing it without one feature of debate is the slowness of the process, right? People have to come to grips, reflect, take time to step back from their position and come up with a new argument. And that is a slow process. And slowness is sometimes a good thing. Slowness is completely lost in the age of algorithms. And it's also done impersonally. Okay, so if we're not paying attention, and again, like when it comes to a society, we do need to pay attention, but it's a little easier to pay attention, right? Because you can kind of see the issues, they're more on display. But in models, it's just some numbers, okay? So if we don't pay attention, if we don't make a choice to pay attention, those trade-offs are going to be made by designers. And a lot of times, they're not even real designers. It's like default settings, okay? But the trade-offs end up being made without accountability. There's no oversight. No one's taking two positions and debating, like, do we want to do this or do this? It's just like click, 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 and they're done, okay? All right, what are some potential solutions? Well, let's start with a bit of good news. The bit of good news is that there are actually good trade-offs and there are bad trade-offs, objectively speaking. Objectively, right? That makes our lives a little easier when you can, right? So there's so much ethics that kind of veers into the subjective territory, and so we can make something objective that makes our lives a little easier. We have good trade-offs and bad trade-offs. What are the good trade-offs and bad trade-offs? Well, that insight, one way to formalize it mathematically is through the concept of Pareto optimality. And so here's a very simple picture of Pareto optimality. So you have F1 and F2, And so for us, that would be accuracy RW and accuracy DS, or accuracy and fairness, if you want to, right? Okay, so what's going on here is you have the filled in dots, and then you have the empty squares. And the squares are dominated. And what that means is that anytime you choose one of those squares, it is not rational to do so, because you could do better on one or both of the metrics, okay? So in any of the boxes, if you choose them, you would say, wait, why are you choosing this box? You can do better on the fairness metric or on the accuracy metric or both at once, right? So why would you choose something that's just purely worse? That is not rational. So in game theory, we would say that the option is dominated. You can do better. You can do better, okay? So that's the good news, is that you have some trade-offs. I mean, all these, just to be clear, all these points on this graph represent trade-offs, okay? But we can say that some of them are we should not want them. So that's good news. That we get some help from Pareto in thinking about good and bad trade-offs. The bad news is that Pareto optimality does not in itself give us guidance about choosing between the undominated trade-offs. And so what you can observe is that there's a series of filled in dots, and all of those are undominated solutions, okay? So they're all different ways to trade off between the two values that we care about, fairness and accuracy. But there isn't any numerical reason to say that one dot is better than another. They're all good trade-offs. None of them are dominated. The only ones that are numerically unpreferable are the white squares, right? Those are the ones that no one should want, okay? But along that line, those all represent different trade-offs. Here's one way to trade off fairness and accuracy. Here's another way to trade off fairness and accuracy. Here's another way to trade off fairness and accuracy. Here's another way to trade off fairness and accuracy. But Pareto optimality gives us no guidance about which one of those trade-offs would be preferable. From the perspective of Pareto, all are acceptable. Okay, going back to this. So, the good and the bad trade-offs. So if you try to make an argument that Society 1 or Society 4 is the best society here, I'm going to challenge you, right? I'm going to say you're not thinking clearly. If you want Society 4, then you're okay with everyone being unhappy, which is a pretty weird moral position. Not a very thoughtful one, I would say. If you prefer Society 1, I'm wondering why. Also, because Society 3 is strictly better, and for that matter, Society 2 is strictly better, right? So putting this in the language of game theory again, we would say that Society 1 is dominated. We can easily do better on every metric. Every one of the three people could do better in Society 2 and 3. So a bad trade-off would be to say that I like Society 1. A bad trade-off would be to say that I like Society 4. Those in terms of the graph, those would be like the white squares. But what about between Society 2 and 3? I think those would be equivalent to the filled-in dots. So, I mean, how do we choose between Society 2 and 3? Well, I've already given you a reason why you might like Society 2, and I've given you a couple of reasons why you might like Society 3. And ethically speaking, we can't just say, people that prefer Society 2 have made a mistake. They are bad people, they're illogical, et cetera, et cetera. You can't say that. You also can't say that people that prefer Society 3 are bad people, they're not thinking clearly. So this is the subject of a debate, right? Do we want a society that's more like 2, or do we want a society that's more like 3? So it's difficult. We have to dialogue with each other. We have to think about ethics really hard. And we have to think about the context of the real world, right? Who are these people? What's their history is, what groups are they part of, etc. All right, those are some thoughts on the fairness accuracy trade-off.